Namaste. We all know that feeling when our internet cuts off and all you are left with is this jumping Dino game. Well, let's make one for ourselves. I'm using Unity 6.2. Make sure you are using a similar version to avoid any discrepancies. First things first, we need our asset files. You can download them from the link given just above the like button below. It is a pretty small file. Download it and make a folder for yourself. Name it Dino Game. Put the assets folder inside it. Create another folder for Unity files. I usually do this to avoid confusion between Unity assets and or regular assets. Open Unity Hub, create a new project. Unity should already choose the best version for you. If not, download it from the Install section. Select Universal 2D and give your project a name. Set the location to the folder we just made, and we will create our project. We don't want to mess with Unity version control for now, so let's wait for the game to open.
One eternity later.
Finally, let's go ahead and set our environment. Create an asset folder, and inside it, let's create 3 folders: sprites, scripts, and prefab. This will come handy when we start populating our game with images and scripts. Let's import all of the image assets. Just click and drag the images inside the sprite folder. Now, it is important to attend to these assets beforehand, as they are pixel art and require some modifications. Select all sprites and set the pixels per unit to 32. All of the assets are made at a base of 32 by 32 pixels, so it is good practice to set them as such. Then, set the filter mode to point, no filter. Finally, set the compression to none and hit apply. We are almost done with our assets. Just one more thing. We need to handle our Dino sprite sheet. A sprite sheet is a collection of sprites on a single canvas, paper, or an artboard. We use it to simplify our animations. For example, in our Dino sprite sheet, we have drawn the legs at different lengths to simulate a walking animation. Click on the Dino sprite sheet and open the sprite editor. We can make adjustments to our sprite here. Set the width and height to 32 by 32. All dinos should be inside the respective white boxes. Select Slice and then click on Slice again. Apply and close the panel. Your sprite sheet has been used to create individual sprites which can now be used for animation. For now, we will work with a static dino. We currently have only the main camera and global light 2D asset in our scene. First, go to the camera and in the environment setting, change the background color to something that is a bit more darker than white. After that, let's add an empty and rename it Dino. This will be our player parent. We will be adding all our code to it. Let's reset its transform to center and scale it appropriately. Create a child empty game object and reset its transform as well. Add a sprite renderer component and drag the sprite sheet in the properties. If you click on play, your Dino should be on the screen, but nothing's happening. Let's change that. Go back to the Dino parent game object and add a rigid body 2D component. If you click play, your Dino should start falling. Great! If your Dino, for some reason, does not fall, make sure the body type inside the rigid body 2D component is set to dynamic. And as we want the Dino to fall a bit faster, we will also be setting the gravity scale to 3. You can go ahead and change the linear and angular dampening to 0, and also change the collision detection to continuous and the interpolation option to interpolate. The Dino is falling, but we cannot play the game if it keeps on falling. So, let's create a ground where it can stand. Create another empty game object and name it background. Reset its transform as usual. We will add all background elements here. Create an empty child object. Name it ground and let's create a sprite renderer component. Adjust its scale and placement. Place it just below the Dino's feet. Hit play. The Dino, again, just falls straight through the floor. This is because Unity has no way of knowing when and where the Dino and the ground collide with each other. To help Unity with this calculation, let's add a box collider 2D component to the ground. Unity should automatically scale the collider if it does not overlap the ground properly You can make manual adjustments by clicking on the Edit Collider button and manually moving it. Go to the Dino game object and add Capsule Collider 2D component as well. Click on the Edit Collider option and make the collider a bit smaller than the dinosaur itself. This is generally good practice as we only want the game to be over if we hit any barriers fair and square. A minor touch should not be an issue. If you now play the game, your dino will no longer fall through the ground. Now comes the part of coding features into the game, like jumping, because obviously it is a jumping dino game. Go to your project panel, then to Assets, Scripts, and create a new mono behavior script. Name it Dino Behavior. Make sure you name your scripts as you want to. Minor mistakes will bring a big headache if you are not careful. Double-click on the script and it should open the IDE of your choice. For me, it's Visual Studio Community 2022. If you have never coded in C#, well, you would do better from learning about it from others who are more experienced and well-spoken than me. But as I have not seen anyone make a Dino game, well, here we are. First, let's create a couple of variables. We will first create a public boolean and name it isAlive. We will set it to true. We also need to check if our dino is on the ground or not to check for jumping. We will also be needing a variable to store rigid body 2D data. Create a new start function and let's set the isAlive value to true, regardless of what we did early on. We also want to set the timescale value to be 1f. F in this context basically represents that our value is supposed to be a float. So we are basically setting the timescale to be 1. That means we are setting it to be normal. We need to access the rigid body component of the dino, so let's do that. Set the value of the dino rigid body to get component rigid body 2D. Real quick, sometimes Unity just fails to grab components, or we might have made some mistakes along the way. It is always best to have a backup plan. So we can check if the rigid body 2D component has been grabbed or not by logging an output if it's null. So write this line of code. We are making excellent progress. We now want our dino to jump. For this to happen, we need to use Unity's new input system. Click on your Dino game object and add a player input component. You can go to the assets and add the input system action asset. This will add the built-in input actions already set by Unity. If you double-click on it, it will show you the same. As we just need the jump action, open up to check which button is attached to jumping. You can close this tab. Now, let's jump back to the code. After the start function, add a public void jump function. This function will require the input action.callback's context variable, which in our case is space. Now, a simple if statement can help us jump. Write the following line of code. You are basically creating a new vector2 value which keeps your x values constant and your y value to the new jump height. You can declare the jump height variable at the top and make it 10f to start with. Go back to the editor and within the Dino game object, look into the player input. Inside events and player, check jump. Drag the Dino game object and inside the Dino behavior option, select jump. This will tell Unity to run the jump function once space is pressed. If you play your game, you should see the dino jumping. However, if you jump whilst in the air, it will keep on jumping. So to avoid it, we need to check if it is grounded or not. While you're at it, you may want to check automask on the dino rigid body as well. We can now work on the update function. And as we are dealing with physics object, it is best to work with fixed object. Create a raycast hit 2D component. This will shoot a line from the origin. If the line intersects any particular object, we can do as we want. In our case, if it intersects the ground, we want to know that it is not in the air and we can jump. Instantiate the raycast hit 2D component with the following line of code. Let's declare the ray length and ground layer variables at the top. Instead of making them public, we can create a serialized field which will allow them to stay private, but they can be adjusted from the game window itself. Now, we can add it to the isGrounded variable with player raycast collider is not equals to null, which basically means check if the collider responds to the ground or not. If it does, then the Dino is grounded, and vice versa. Finally, add the isGrounded variable into the jump equation with the callbacks context started. If you want to check the length of the raycast, you can create a debugger for it. Simply write debug.drawArray, transform position, vector 2 down, multiplied by the real length, and choose a color. In our case, I'm choosing yellow. You should see a yellow line being drawn from the center of the Dino. Finally, we now need to tell Unity where our ground is. Go to the ground game object and in the layer option, click on Add Layer. In the user layer 6, add ground. Click on the ground game object once again, and make sure to assign the ground layer to it. Go to your Dino game object and select ground in the ground layer option. Now, your Dino will not fall off of the ground, and it will only jump once it falls to the ground. Let's take a break and talk about something important. You. How are you doing? Is the pace to your liking? Have you run into any difficulties until this? If there are any queries, please feel free to leave them in the comments, and I will try to solve them as best as I can. Again, I am no expert in Unity nor in C#. I'm not even an intermediate level. But I did manage to make this game and just wanted to share how I did it. If you like such content, please feel free to like and subscribe. It will help me out a ton. It will also keep me motivated to make more content in the future. Thanks. So, now that we are back, we need to address the elephant in the room. We have got the Dino to jump, but we have nothing to jump against. It is all empty. We now need barriers. For this, let's create an empty game object in our scene and reset its transformations. We will rename it to barrier. Let's add a sprite renderer and a character sprite to it. Then add the rigid body 2D and change the body type to static because we don't want it to move. We also need to add a collider. So I'm going to use a box collider for it, and I will manage the size as required. Finally, let's create a new script. We'll call it barrier behavior. We will add the script to the barrier game object. We now have a base for our cactus barrier. So what we can actually do is turn it into a prefab. A prefab is basically like a reusable game object. These act as templates of the original game object and can be instantiated with the same behavior as the original game object. In order to make a prefab, we will drag the barrier game object into the prefab folder, and that's it. Let's go back to the barrier behavior script and make a few adjustments. First, we want to note how fast the barrier, in our case, the cactus, will move, and we want a way to destroy it after it exits our screen. This is because we don't want to spend computational power for something that is no longer visible and that we no longer need. So let's create a couple of private floats, namely the speed of the barrier's movement and the exit distance for it. We will add a serialized field to it and make adjustments from the editor itself. Give it a value of 5, screen exit, give it a value of -10. We will also need to know if the Dino has touched the barrier or not. Let's get its rigid body as well. We'll get a private rigid body 2D, name it barrier rigid body. We can start by getting the barrier rigid body with getComponent rigid body 2D. Then we can work on its uniform movement. Create an update function, and we can translate the barrier to keep moving towards the left at a set speed. Transform.translate moves the player towards a certain direction. In this case, the vector2.left defines the left movement at the speed of barrier movement speed. We add time.delta as to make the movement frame rate independent. You can Google it and get more detailed answer. Or I will create a new video in the future if required. Let me know in the comments below. Then we need to destroy it after a while. So if transformPosition.x is less than the screen exit value, then destroy the game object. This will destroy the game object once it exceeds the directional limit of the screen. If you play the game, the Dino will collide with the barrier, and you can see the barrier being destroyed after it reaches a predefined distance from the origin. But the problem is, only one barrier is being spawned. In order to continuously spawn these barriers, we need to create a new game object and name it barrier spawner. We want to keep it just above the ground and exactly out of sight for spawning. Let's create a new script for it and name it barrier spawner. You can delete the prefab that exists in the scene. We want a couple of variables for it, namely the minimum and maximum spawn intervals. We also need a private float timer and a way to access our barrier game object. So, write the following line of code. Fun fact, if you create a header, it will help you segregate your properties in the properties panel. This is just a nice way to manage your stuff. Now, we can create an update function which will spawn objects at set time. We can start by increasing our timer value with time plus equals to time.tilde_time. This will add time.tilde_time to the timer value. We can then create an if statement and say if our timer is greater than the max spawn interval, we can spawn a barrier and reset the timer to 0. So, write the same. If the timer is greater than or equals to the max spawn interval, spawn a barrier and reset the timer to 0. We can quickly create a new spawn barrier function below, which will spawn new barriers at the end of the timer. Private void spawn barrier. Inside it, we can add instantiate the object we want to instantiate. In our case, it is the barrier object, and transform that position, name.identity. What we are saying with this is instantiate a barrier object at its transform position with its original rotation. Go to your editor and add the barrier spawner script to the barrier spawner game object. You can add the prefab to the prefab property. Save, and if you hit play, you will find the barrier spawner working charmingly well. The Dino collides with the barrier, but nothing happens. We need to create a mechanic to stop the passage of play and allow for a game restart. In order to do that, let's refer to our isAlive variable for our Dino. We had set it to true in our start function in the Dino behavior script. If we go down just before the jump function, let's add an inbuilt function that detects collision properly. Type on collision into 2D and the function should be ready. This function looks to output a result once you have collided with a collider. In our case, we want it to stop the game once it has collided with the barrier. So let's do that. Create an if statement and use a function that compares tags. Tags are basically identifiers that are used in Unity. Just name one as barrier for now and remember the spelling as it will be important. Even the capitalization. Add a debug.log barrier hit. Debug to get this thing started. Open the editor and go to your barrier prefab. Open it and inside the prefab, go to the tag option. Add a tag and name it barrier. Go back and make sure the tag is attached to the prefab. You are basically creating an if statement which checks if the game object is basically colliding with something that has the tag barrier attached to it. So if you play the game, Unity will output the debug log, which is perfect. Go back to the script and add a couple of things to the collision function. Firstly, you're going to set the time.timescale value to 0 as you want to stop the time. Then you want to change the isAlive value to false as you want the Dino to not be alive. You can add the isAlive variable after the isGrounded variable in the jump context to make sure the jump only happens if the Dino is alive. The main part of the game is done. Now, we just want a way to display player points and restart the game once the player dies. First, let's focus on the score thing. Create a new canvas. In the canvas scaler, under UI scale mode, select scale with screen size, and in the reference resolution, set it to 1920 by 1080. As we have also used most sprites that are 32 by 30 pixels in resolution, it is best to keep the reference resolution to 32. After that, create a new TextMex Pro game object. Unity can prompt you to download assets for TM Pro. You need to download these essential materials. You may choose not to download the examples as they are not compulsory. You can rename it to Score, change the font size, and move it a bit to your liking. Create a new script and name it GameScript. Drag it to the main camera as we want it on a game object that will be present throughout the duration of the play. We can create a couple of variables. First, let's access the Dino behavior script by creating a serialized field and naming it DinoScript. Then, let's create a private player score variable and keep it at 0. We can then create a score to display variable to keep the score to display. Finally, we also need one score timer float to tie things up a bit. In the update function, first add the score timer. Score timer plus equals to time.tilde_time. So we are basically increasing the score timer by the time. After that, we can basically check if the score timer is greater than 1, then we can add 1 to the play score and we can reset the score timer to 0. We are first checking if the score timer has exceeded 1 second. If so, the play score will go up by 1 and the timer will reset to 0. This will then update the score text. We can add the update score text function just below everything else. Private void update score text. Score to display.text equals to add a text. This is not compulsory. Score colon and give a space plus play score dot to string. This will output the play score integer value to string. Go back to the main editor screen and drag the score text to the score to display property. While you are there, drag the Dino behavior in the Dino script as well. If you hit play, your score should update properly. We are almost done. We just need a button which can help us restart the game. Add a button text mesh pro within the canvas. In the button, you will be able to see the image properly. Go to your sprites folder and drag and drop the button base 0 file to the source image. Go to the properties and set the width to 96 and add the height to 32. You can set the position any way you like. Rename it to something like restart. Inside the button, add a DM Pro text element. Center it to the button and set the font size. You can rename it to restart. After that, open the game script, create a public function, name it restart game. In it, we'll ask Unity to reload the same active scene, which is our main game scene. As we have not renamed it, it is probably called something like a sample scene or something as such. But we can use getActiveScene.name to get the name of the active scene that we are currently playing on. And we can reload it without any hassle. So no need to go about changing the name of the scene. On the restart button, go below and you will see on-click property. Drag the main camera in the empty place below and it will automatically outline the game script. Open this tab and in the game events option, you will find the restart game function. Click on it and pressing the button will run the script. There you have it. The final game is done. Play the game and pat yourselves on the back as you have created something that can be played and enjoyed by everyone. That being said, there are many more things that can be done. You may want to randomize the barrier movement or even its point. You may want to create a day-night cycle or a flying asteroid object. Furthermore, as there is already a spreadsheet, you may want to animate a dinosaur. Whatever it is that you want, you can now do it on your own. And if you are having any problems or if you have any queries, please feel free to ask them in the comment section below. And I will try to make an update video if required. Namaste, farewell, and happy gaming. See you in the next one. If you are liking this content, you can help me out by simply liking and subscribing. If not, leave a comment on how I can improve. Thank you.